out. And then number 11. Usually I put this problem on the test, so I guess the probability is 0.9. But I think last year, we just didn't have time, see, because this year we got an extended, last year there wasn't, so we didn't have time to discuss it, so that's why this problem wasn't on last year. But this year, we're discussing it, so it will be. Now that I told you that, it won't be. But now that I told you that, it will be. How many people got at least a 1A? How many people got 1A? One person. Weird. You guys are in trouble. Here is a wire. It's 1 meter long. I'm going to cut it into two pieces. One, I'm going to bend into a square. So this one bend into a square. This one you bend into a circle. You have to understand the problem. X represents the amount of wire used to make the square. Therefore, how much is what is this to make the circle? 1 minus x is bent into a circle. Find x so that the sum of the areas of the square and the circle is a minimum. Okay, we might only have time to do 11a. Okay, I'll just hold you responsible for 11a. Forget 11b. Okay, so I need to write a function for what? The sum of the areas. Okay, now if this is x, and I bend it into a square, isn't each one going to be x over 4? So what's the area of that square then? X squared over 16, correct? Okay, now what about the circle? This 1 minus x is the circumference of the circle, right? So that means 2 pi r is equal to 1 minus x, right? Circumference is 2 pi r. Therefore, the radius of the circle is 1 minus x over 2 pi. Therefore, what's the area of that circle? Pi times that thing squared. 1 minus x over 2 pi squared. Pi r squared. I'm assuming we know 2 pi r and pi r squared, right? There you go. And look, what kind of function is this? It's a quadratic function. Do we know how to find the minimum of a quadratic function? The vertex? Yes, negative b over 2a. Okay, but here's the hard part. You have to multiply this out and put it in quadratic form. See that? Most students could do this. I give you 2 points for that even. You want the other 6 points, you got to compute negative b over 2a. How do you do that, Mr. Buck? Okay, multiply it out, man. Just do it. Go.
1 minus 2 plus x squared.
Over 4 pi squared. But then this pi cancels that pi. Okay, here. At this point, okay, let's just see if you can do this. We need to put it in quadratic form, like this. This is quadratic form. Let's just see how good you are. There are two x squared terms. One here. Do not multiply both sides by 16 pi. Every year there's always clowns that do that. If you multiply both sides by 16, see, this is not 0 here. This is the area. You're changing the function. You know what I'm talking about? If this was 0, then you could multiply it through by 16 pi, but this is not 0. It represents the area. So you cannot multiply it through by 16 pi. Okay, I have two x squared terms. What's the coefficient? What's the coefficient of this x squared? 116. And what about this one?
4 pi.
1 over 4 pi, right? When you have something plus something over something, you have to divide everything by that something. Look, a plus b plus c divided by d is a over d plus b over d plus c over d. Come on, it's algebra 1, right? Okay, here. Here's the only x term. What's the coefficient of x going to be? It's this over that. What is negative 2 over 4 pi? Oh boy. Negative 1 over 2 pi. And there's only one constant term, that's this. What is that? 1 over 4 pi. There you go. Now it's in quadratic form. Okay, so here's a quadratic function. And since the leading term is positive, you know it's going to open up. So the minimum occurs here. How do I find the vertex? Negative b over 2a. So here's a, b, c. Negative b, how? Write it up. Negative b all over 2a. This is a 1/16 plus 1 over 4 pi. I changed my mind. The probability of this being on the test is 1. This is on the test. There you go. That's the answer. That's the answer right there. All you got to do is simplify. That could pose a problem, Mr. Park. Okay, let's go. 1 over 2 pi, and then you have 1/8 plus 1 over 2 pi, right, if you distribute the 2. Now, when you have fractions within fractions, what did I tell you to do? Multiply top and bottom by the least common denominator of all fractions, which is 8 pi. Multiply the top by 8 pi and you get 4. Oh boy. Multiply this by 8 pi, you get pi. Multiply that by 8 pi, you get 4. There's your answer. So, you make this 4 over pi plus 4, which is about 4/7, and you make that about 3/7, and then the sum of the two areas will be as small as possible. Because pi is a little bit bigger than 3, yeah? Anyway, like I said, we don't have time to do B, but just how would you do B? This is the minimum. Where's the maximum? Because, but Mr. Park, because the parabola keeps on going up forever, there's no maximum, is there? Oh, yes, there is. That's because the domain of this problem is, what's the smallest x can be? 0, but what's the biggest it can be? 1. So if you restrict the domain to be between 0 and 1, then the parabola looks like, it actually looks like this. And so there is, so in other words, it stops here and here, so there is a maximum. In other words, you use all of it, wait a minute, 4/7. Or is it the other way? Which way is the parabola? This way or this way? See, if it's this way, then you to get the maximum, then, oh no, that's correct. It looks like this. It looks like this. That means x is what?
The lowest one, 0.
X is gonna be 0. That means you don't use any of it to make the square, you use all of it to make the circle.
Circles are more efficient, or more efficient in terms of the.
Well, see, that's what you guys think. But you don't know until you actually work out the math. Anyway, so this problem's gonna be, let's see now that I told you it's a square and a circle, what if I change it to, like, what did I do 2 years ago? I made it a square and an equilateral triangle. But now that I told you that, we'll make it a circle and an equilateral triangle. Now that I told you that, it'll be an equilateral triangle and a hexagon. Now that I told you that, it'll be an octagon and an equilateral triangle. It's going to be 2 shapes. I'm not going to tell you what they are. So I told you almost the whole test. If you can do these problems, it's going to come from, it's going to be one of 8 of these problems right here. Right here. And maybe I should bring back the Pokemon cards. You can sell this many cards for this much, but then if you reduce the price by this much, yeah, maybe I'll bring back the Pokemon cards. Or maybe I won't. Oh man, we just barely finished. How can you cross this up?
So that was, because I counted this stuff and
Okay, I'll give you 2 more points. Oh man, what is going on?